Yeah, good morning or good afternoon, all of you. So we begin with our lecture today. So after a gap of almost 2 weeks, we are having this lecture. So we were doing SNMP version 1. Okay, so the objective of today's lecture is we will understand about the SNMP default UDP ports. I had mentioned while explaining the SNMP architecture that when the agent and the manager is communicating with each other, okay, so and whenever it is an SNMP communication, SNMP uses UDP in the transport layer. The UDP is the protocol that is used. So they communicate only using two ports. Okay, so they are called as the well-known ports for SNMP communication. So that is the term that we use. So any port number we cannot configure for SNMP communication. So we will learn a little bit about those two ports, how the manager and agent are communicating, and then we will know about the various traps. See, in the SNMP version 1 architecture, we had seen that the agent and the manager communicates using those 5 messages. So one of the messages, a trap message, which the agent sends to the manager. Okay, so we will study a little bit about the type of trap message, okay, and a little more detail about the trap message. And then we will study about the various PDU structure. PDU structure means if I'm sending a get message, if I'm sending a set message, or if I'm sending a trap message, so what will be the structure of the data unit? Okay, what are the various fields? So this is an important topic from the viewpoint of a subjective exam. Last year we did not have a subjective exam. It was an MCQ entirely, but since you people might have 40 marks MCQ and 40 marks subjective, so the types of PDU and their structure, so you can expect one question from it. So those who are making a note or writing somewhere, you can write an INT from the viewpoint of a subjective answer. There you are drawing the field structure and explaining about each and every field. Okay, so the learning outcome will be, you will learn how SNMP communicates using two well-known ports. Okay, so this word is highlighted. So it is called as two well-known port. मतलब इसके बिना SNMP communication है ही नहीं. You cannot set up an SNMP communication if you don't know कि हाँ मुझे एजेंट का पोर्ट ये सेट करना है और मैनेजर का पोर्ट ये एड्रेस सेट करना है. Okay, so that's why we call it as two well-known ports. And also we will know about the get, set, and trap PDU structure. Okay, so this important from the viewpoint of a theory exam. Okay, so just a diagram to explain those two ports. So here I have the management station, so I can call it as the manager, and here is the network elements, or here you can call it as the agent. So, and all the layers, they are not necessary. So what it is indicated that any message generated from the agent, okay, is received by the manager at port number 162. So you can see it's unidirectional. Now, any message, we know that the agent generates, this diagram I took from the internet. Okay, so any message that from the agent, okay, so agent, we know they generate only the trap message. Okay, so the trap message is generated by the agent and it is received at port number 162 of the manager, or you can call it as the management station. Now the manager will generate the remaining 4 message. Total 5 message hai. Trap is generated by the agent and the remaining 4 is generated by the manager. So any message that is generated by the manager, or you can call it the management station, will be received by the agent at port number 161. So you have to remember this. The trap message generated by the agent is received at port number 162 of the manager, and any message generated by the manager will be received by the agent at port number 161. To explain this diagram, I have another diagram to explain how the manager and the agent communicate. So how the port numbers are managed. So here in the diagram, they have mentioned client and server. Okay, so client server model they have explained the SNMP. Now we know that the client is our manager now in this case. server is the agent. Many times students feel server, he's serving the purpose. Okay, so he's the more senior. So यहाँ पे manager लिख देते हैं. Okay, and client is to whom we are providing the service. So lower level है. So यहाँ पे agent. Remember, client here in SNMP is the manager, because see, the manager is asking for the data, and who is giving us the data? The agent is giving us the data. Okay, so since the agent is giving us the data, he takes the role of the server. All the data is with the agent, and only when the manager is asking the data, the agent is giving. So that's why the client is the manager, the server is the agent. Okay, so this part, you keep client and server, but you write यहाँ पे manager role here as the agent role. So from the previous slide, we understood that there are two ports for communication, 161 and 162. So here, the client and the server, they want to communicate. So they have these ports 161 and 162 as passive open. Okay, so I will explain all the with respect to these three diagrams, that is ABC. So passive open by both the client. Then there is an exchange of request and response message. I'll explain each again, but just I'm telling what are there in this slide. So then there is a passive open, means they are in the listening mode. Okay, so once there is a need for data exchange of request and response message, then they are in the active open. Now active open में दो चीज होगा, either the manager is sending the data or the agent is sending the data. So that's why we have active open two cases. Okay, so this is the listening mode. They are waiting for somebody to initiate a communication, and this is when the data exchange is taking place. Here you can see it is bidirectional. Here you can see it is unidirectional. Okay, and this is passive open for both the manager and the agent. So now let us understand A, B, C separately. So the same diagram over here. So SNMP uses the services of UDP on two well-known ports, 161 and 162. So the well-known port 161 is used by the server, or you can call it as the agent, and the well-known port 162 is used by the client, or you can call it as the manager. So the agent or the server, it issues a passive open on port 161. It then waits for a connection from the manager, or you can call it as the client. Echo, I have kept manager, client, agent, server, both. We don't know in what way, because SNMP, we are using the term agent and manager only. But suppose if the question comes, somebody just refers only TCP/IP by 400. Okay, SNMP is taken from that chapter, and he, instead of server and client, don't get confused कि हम लोगों ने तो agent manager ही पढ़ा था, server client कहाँ से आ गया. Okay, so that's why I have kept both the things, so you should not be confused. Okay, so the agent issues a passive open on port 161. It waits for a connection from the manager. The manager or the client, it also issues an active open, and then see, active open जब manager open कर रहा है, what he is doing, he is using any empirical port number. So randomly any empirical port number is mentioned over here. So the manager issues an active open using an empirical port number. Agent issues a passive open on port 161. That is what you have to remember. So then the request message are sent from the client to the server using the empirical port number. Manager को कुछ data चाहिए client को. So that data he will send it using any empirical port number. So randomly यहाँ पे कुछ 58 या 68000 लिखा हुआ है. Okay, so the request message sent from the client to the server using the empirical port number as the source port. So this is my source. He has sent a request, but the destination port, that is the agent, it should have the port number as 161. Then what happens once the client sends a request to the server, that is the manager sends a request to the server or the agent, then the response message are sent from the server to the client, or you can say agent to the manager. So यहाँ से request भेजा और यहाँ से response गया. So that's why this is bidirectional. So, but remember, the agent will transmit the data, the response from port number 161 to any empirical port on the manager. So यहाँ पे any था और यहाँ पे 161 port था manager. So this is how the manager, when he's issuing an active open using empirical port and receiving that response from the agent using a fixed port number, that is 161. Okay, so this was the manager or the client asking her data from the agent. Similarly, the next slide is the manager, it issues a passive open on port number 161. यहाँ पे जो था, it issues a passive open on port number 161. It then waits for a connection from the agent. Okay, so it is waiting for a connection. Now, whenever there is a trap message to send, okay, an agent issues an active open. Okay, if he has sent some data to send, then he will issue an active open. Now, active open, he will issue at any port number. So that's why your random port number is there. यहाँ पे any लिखा हुआ था. Okay. So the client server mechanism. Now remember, this connection is only one way from the server to the client. Okay. Manager has not asked for any data. He has issued a passive open. He has some data to send the agent. So using any empirical port number, he is sending the trap message, or you can say alarm message, to the manager. That's why it is one-way communication. The client server mechanism in SNMP is different from other protocols. Here, both the client and server are using the well-known ports. Other communication may, this is not the case. Okay, but only in SNMP, it's a little bit different because they are supposed to use this port number 161 and 162. In addition, both the client and server are running infinitely. The reason is that request messages are initiated by the manager, but the trap messages are initiated by the agent. So that's why we need this two empirical port number. I hope you understood with this diagram. Okay, so now what will be the addressing scheme and the operation of the protocol entity? So the protocol entity that generates the message constructs the appropriate data, PDU, and it will be as an ASN1 object. It then passes the ASN1 object along with the community name and the transport address to itself and the destination. So when I am giving the destination address, I am mentioning the port number. Okay, and then it goes to the authentication scheme. The authentication scheme returns another ASN1 object, possibly encrypted, but nothing much is given over here because we have only those 5 commands. Okay, and we are taking care of security or by the or access using your community name, or you can say community profile. So the protocol entity constructs the message to be transmitted with the version number, the community name, and the ASN1 object. Now, how this PDU is constructed, since it's a gap of 2 weeks, I'll just show you. We have already done this. Okay, so don't feel कि ये ma'am क्या बोल रहे. How I am structuring or creating the PDU. So I have the data. Each layer is attaching their header. Okay, so at the application layer, I am attaching the application header, the version, community, and the PDU. And then it comes down, it goes to the physical layer. And at the, suppose this is at the manager side, at the agent side, again the reverse process. So this is how the protocol entity is created. Only this particular slide is telling that how the addressing we are giving. Okay, so suppose this something dot something dot something, and we are specifying the port number. Okay, and all this is done using the ASN1 coding, and how I am transmitting using the basic encoding rule. So we have seen the TLB encoding, how it is converted into streams of ones and zeros. Okay. So this already clear. Again, I'm just showing you the same diagram, the architecture of SNMP version 1. So here we have these 4 messages and 1 trap message, which is generated only by the SNMP agent. So there are, what is trap message? Trap message means an alarm. Okay. In OSI, we were using the word notification. So alarm means something has happened and I'm telling the manager. Okay, so what are the types of trap? Okay, something has happened means what has happened? Link failure hai. Okay, some connection is lost. What is actually I'm considering is as an unwanted situation and I want to raise an alarm. Okay, so then there are some kinds of trap message. Okay, so what are those types of trap message? Uh, okay, so just a moment. Okay, so there are three types of traps. I think I missed that one slide. Okay, but it is present over here. So there are, this question was asked in Viva last time, the examiner was asking. So what are the types of trap message? There are three types of trap. Okay, so one is a generic trap, the other one is a specific trap, and the third one is a timestamp. Okay, so anybody who is noting it down, making notes, because earlier students used to write, draw, everything. I don't know what you people are doing at your end. So there are three kinds of trap: generic trap, specific trap, and timestamp. Okay, so generic trap is again of 7 types. Okay, so we will see what are those 7 types of trap. Then there is a specific trap. Specific trap is a trap that is not covered by the enterprise specific trap. So what is enterprise specific trap? We will see. And the timestamp, it indicates the time elapsed since the last reinitialization. Now you will feel, are ye trap kya hai? Now this generic trap is of 7 types. Okay, so what are those 7 types? So from the name you will नो कि हम लोग किसको अलार्म बोल रहे हैं या क्या बोलना चाह रहे हैं. Okay, what is that unwanted situation? So the 7 types of generic traps are cold start, warm start, link down, link up, authentication failure, EGP neighbor loss, enterprise specific trap. And with all these 7 names, there is in the parenthesis, or you can say in the bracket, there is a number associated. See, when I am generating the PDU, okay, the data unit, I have to fill in the data. अगर मुझे पता है कि 5 मैसेज है, उसमें से I am using the trap. I am sending a trap command or a trap message, and in the trap also now I have these 7 types of generic trap. So whether I want to indicate कि link down हो गया है या link up है या authentication failure, so I will not type in this whole name. I will just fill the field with number 4. So अगर suppose in the trap message, that parameter, I fill number 4. Okay, so it is decoded कि हाँ, there is some authentication failure. Okay, so the agent notifies कि हाँ बाबा कुछ तो authentication failure है to the manager, and then the manager will take a decision. So we are not bothered कि manager क्या decision ले रहा है. It is now suppose I'm playing the agent role. It is my duty to just inform the manager that this particular object or this particular node, either it is up, it is down, or there is some authentication problem, and then whatever, it's just my duty to inform, and then whatever decision let the manager take. Okay, now what is cold start? Okay, so there is a table given in money. Okay, so I have taken this table entirely from money. So what do you mean by cold start? I mean, cold or warm start kya hai? So what is cold start? Just see the definition. So the description is written. Sending protocol entity is reinitializing itself. Agent's configuration of protocol entity implementation may be altered. Okay, so this notification the agent wants to send. So he will fill the field with 0. Now warm start. Sending here it looks almost the same. Sending protocol entity is reinitializing itself. Agent configuration of protocol entity implementation is not altered. Okay, so that is, I want to give an indication. So it is called as warm start. Link down. Okay, so from the name we come to know failure of one of the communication link. Okay, so that is, I want to tell you about ye link down hai. So I will put in the field 2. Okay, so that indicates it is link down. Link up. Okay, suppose after some time this link might have come up. Okay, I want to tell the manager. Okay, so link up is one of the link has come up. Then authentication failures. This is explainable. If there is some problem with the authentication, if some unwanted components have entered the network or trying to access the network. Okay, so I need to notify the manager. Okay, so then authentication failure, and then loss of a EGP neighbor. So then enterprise specific trap. If I am in a, see what is enterprise specific trap is, I am in a certain organization. Okay, in industry we call it I'm in an enterprise. Okay, so for an enterprise we have some alarms or some messages. Okay, so that is covered in this enterprise specific trap. Okay, so if I am having some Alexa trap message or a different kind of trap message, that falls in enterprise specific trap. So these are some of the trap message which falls in generic tab. A link up here, down here. Okay, some protocol entity is altered, some is not altered. There is problem of authentication. There is lots of immediate neighbor. Okay, so all this are the trap message, and then I have some specific traps, okay, which is related to my enterprise. So all these 7 kinds of traps falls in the generic trap. Now what was there in the specific trap is, a specific trap is that is not covered in the enterprise specific trap. Okay, हम बोल रहे हैं कि enterprise का भी एक अलग सा specific trap है, but suppose there might be so many problems in a network. Okay, here only you can see that 6 and then 1 enterprise specific trap was there, 7 are addressed. Okay, so apart from that enterprise specific trap, if there is some other traps which are not covered, okay, so that is covered in the specific trap. So here no much information is there because it is left to the individual enterprise or organization for that trap message. Then the third type of trap is the timestamp. It indicates the time, elapsed time since the last reinitialization. Okay, I had received a trap message. Okay, वो last trap और अब के वक्त कितना time gaya, so that is indicated by the timestamp. So this was something I wanted to explain you about the type of trap. Now let us understand the PDU structure. So the PDU structure as such, it should be trap PDU, 5 PDUs, but some PDUs are common. So let us see what are those PDUs. You are supposed to know this PDU or draw this PDU structure. So for the ASN1 construct for get and set type PDU. So for get and set, it is the same PDU structure. Now some new names or terminologies will be there. So here there are, the first field is the PDU type. The second field is request ID. Now whenever you are writing this, remember request ka R capital, ID ka ID capital. Okay, so that is how you will draw. Okay, then the third field is error status, error index. Then here I have something called as wherebind1 name. What is wherebind? I'll tell you, it is just above in the same slide. Then I have wherebind1 value. Similarly, wherebind2 name value and so on till wherebind n name and wherebind n value. Now what is wherebind? Wherebind is the pairing of variable and value. Okay, it is called as variable binding. So I have a variable. Okay, so we have objects. Okay, every object has a value. Suppose the object is a timer or it is a counter. Okay, so the counter is a variable or you can say an object, and that object will have some value. Okay, so the pairing of the variable and value is called as wherebind. Okay, so wherebind, there might be many objects, okay, many variables in my network. So I have the wherebind1 name. So I specify the name, and then immediately after that I have the value of that particular variable. So depending on how many variables I have, I am specifying over here. So a managed object is a scalar variable and it is simply called a variable. Associated with the variable is its value. The pairing of variable and value is called as variable binding or wherebind. The data PDU in the message contains a wherebind pair. Okay, for efficiency's sake, a list of wherebind pairs can be sent in the message. Okay, so for example, here we have n instances of wherebind pair. So it's not necessary that हर अलग अलग वेरिएबल एंड इट्स वैल्यू के लिए आई जनरेट अ डिफरेंट PDU or different message. Okay, I can have many variables, it's along with its name and value in one message. Okay, now what will be the PDU type? So we have seen there are 5 types of PDU: get request, get next request, set request, get response, trap. So when I have the first field as PDU type, what I will do is, suppose I fill in 2 over here. यहाँ पे field में मैंने 2 डाला. So 2 means it is a set request. Suppose I put over here 4. So 4 means जो message or data में encapsulate करके भेज रही हूँ, it is the trap PDU. Okay, so this PDU type I will fill in with 0, 1, 2, 3, 4, depending upon whether it is the get request, get next request, set request, get response, or the trap PDU. So the first field indicates ये जो 5 PDU है उसमें से कौन सा मैं भेज रही हूँ, whether it is set request है या get response है या get request है और trap है. So I hope you all are understanding what I'm trying to say. Yes. Yes. Any confirmation?
Yes, ma'am.
Only one person yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
It would be better if you people draw at your end this diagram. Okay, as I said, it is an important question from a theory point of view. If you see the previous question papers also, you can make out that this question has been asked. Okay. So then comes the next field. Okay, so the next field is the request ID. So what is the request ID doing? The request ID is used to track a message with the expected response or for a loss of message. So suppose I have requested for some data, okay, from the manager has asked for some data from the agent. Okay, so obviously there will be a request ID because the manager is asking for multiple data from the manager as and when required. Okay, so whenever I'm suppose right now I am asking for some data, so I should know, okay, so this is my first request. Okay, so I give it some number, then after some 1 hour I again ask for similar kind of data from the same object or from the same network element. So I give request number 1, request number 2. Okay, so then there is a request ID. Okay, so why? What is the purpose of that request ID? It is used to track a message with the expected response or for a loss of message also. Then next comes the error status. Okay, see, whenever I am sending or receiving the message, if you have noticed when we were discussing about these 5 messages between the manager and the agent, the manager is sending the data, get request. The agent is sending a response. Now in CCN also you have studied that whenever I'm sending a data, there is an acknowledgement scheme. Okay, yes, the packet has been received, and then some again response. When the response comes, again an acknowledgement. So the manager and the agent know कि अरे बाबा मेरा request वहां तक गया है. Okay, so here we are not sending separately an acknowledgement message. So here in the PDU itself, we are including a field that is the error status to indicate that an error has occurred. Okay, now in error has occurred, so either I will fill in that value. So the value is filled with null, in whose case whether it is not applicable. Okay, just say such as in get request, and then I'm sending the field PDU कि get request जब मैं भेज रही हूँ उसमें कोई error नहीं आएगा. But whenever I'm getting any response, might be there is some error. Okay, so if there is no error, I will fill that value with null. Then error index, after the error status, the fourth field is the error status. It is used to indicate that an error has some additional information on the error status. Like, okay, so what additional information, like whether the packet was in error, okay, the port, it was received on some other port, okay, it was meant for some other manager, okay, SNMP was not enabled on that port. Okay, so some kind. managed, one might be a managed object, one might not be a managed object. Okay, so there are different kinds of error. So it just not only indicates that there is an error, but it will also provide some additional information on the error. So that is what is the field that will be filled in the error index. And remember, all this entire coding, okay, see, this is the field, and whenever I'm writing the message, I'm constructing, I'm using the ASN1 coding. So in the ASN1 coding, that table, there will be a definition कि ये error है, and this is the keyword that I will be using for that error index. So simply I cannot type in any statement कि ये error है. Okay, so those errors will be listed, those additional information on errors will be listed, and a keyword will be mentioned. Okay, since we are not going too much deeply into the coding, but I have uploaded one document in the Moodle. So those who are interested in further about the ASN1 coding and TLP BER scheme, so you can go into that detail. But remember, there is a table that where the errors will be mentioned and the keywords also will be mentioned. Okay, now suppose the error part is over. Then I need to include what are the variables that are there. So here I will include, suppose there are 5 objects and I want to send the data of all the 5 objects. So it will be variable binding 1, 2, 3, 4. If I'm using 0, 1, 2, 3, 4 or 1, 2, 3, 4, 5, it depends. Okay, so I have the variable binding. At first field in the variable binding, I will provide the name. Okay, because we know that every object has a name. Okay, and then that object has a value. This we have seen earlier also. So, har ek object ka, okay, if I say printer 1, okay, a display monitor 2, so that will have a name. So every object has a name, and this name is reflected in the database. Okay, so I have to go with the name. Okay, suppose there is some problem in one of the router. Okay, and the router is my 5th object which I have given. I have listed that router as the 5th object. So what I will do is I will fill 5th in variable has an error. So if suppose the error is in the first object, so I will write, for example, 1 if error has occurred in the first variable, 5 if the 5th variable has an error, and so on. So this error index will or the error status will let us know where or which object has an error. Okay, so this is about the get and set type PDUs. So continuing with this, anybody has any doubt? Because it is just some piece of information that I am telling you. Any doubt till this point? Yes? Anybody? It's like one-way communication. Okay, now I had explained you the types of PDUs. Okay, generic trap, specific trap, and timestamp. Okay, so here the trap PDU. So see, this structure and the previous structure is different. Okay, so if the question is asked, they will ask you get and set type PDU or explain the trap PDU. So if the question comes, explain the trap PDU. So you will start with the types of trap. Okay, and then you will start with this one first, the generic trap. Okay, and after that you will draw the trap PDU. Okay, so here we have the PDU type, enterprise trap, the agent address, the generic trap type, the specific trap type, the timestamp, and then which of the object is in error that I am going to specify. So specific trap type, generic trap type. So what we are going to do over here कि मुझे कौन सा trap है, कौन सा alarm raise करना है. So suppose authentication failure 4. Okay, so parenthesis we have written 4. So here I will fill in the data 4. Okay, and which agent has generated, because in an enterprise there are many agents. So which agent has generated that trap? Kind of trap. So here I will fill 4. So I know ki, this is the kind of trap or the notification that the agent wants to give. If the specific trap is there, then I will fill in that data. Otherwise, I will keep it as null. And I have to provide the timestamp. So timestamp will indicate when I had generated the last trap, because many times it happens that the agent is constantly sending the trap message. If that situation happens, means there is some serious issue with my network. Okay, so I cannot be having a network where there is constantly a trap message, because see, those are the networking or management related message. It is actually not dealing with the actual functioning of the network. And we have done the very first practical also, where we are seeing just by generating that ping message, okay, we are occupying the capacity of our LAN network. So if the agent keeps on sending the trap message, again it is going to utilize that capacity. Okay, so if something is happening, okay, there might be a situation the agent wants to tell many things has happened at that end network end, and he has to constantly send the trap message. So the performance monitoring team will then take up that data, and they will see why so many trap messages were generated. So can I improve the performance of the network? See, all these are interrelated. Okay, aisa cheez ho gaya. It is not only the fault management team who will come into picture, okay, or the installation and maintenance team who will come into picture. And ठीक है, trap message hai, so link is down, so let us work and put up the link or solve or replace the link. No, the performance monitoring team will see why that link is going down. Is there a congestion? Is there more traffic during that point of time? So all you can say all FCATs will work in coordination with each other. So that's why the timestamp is included, and again all the objects that are handled by the agents that are included over here. I hope this is clear.
Yes, ma'am.
Okay, so with this we partially finish the SNMP version 1 architecture. So version 1 architecture, you will have to explain the communication between the agent and the manager using those 5 sets of commands, and these the PDU structure. That is what is explained over here. Then comes the next part is the MIB, the database. Okay, so what is the database extension that takes place over here? So actually this was, since you people are not drawing and I am constantly speaking, so this was supposed to be in the next lecture. So communication protocol we have seen. Now something about the database. How is this database maintained? Okay, so in SNMP we are using the MIB2 database, and also some information about the system group. Okay, so what we will be learning, again I will just cover a little introduction about this, and we will take it up in the next lecture, because it's a full one topic that is there. So the students here, you will learn about the MIB2 in the SNMP version 1 and the MIB2 tree. Okay, see, when I say I install SNMP in my system, okay, using OpNet we can install, or Cisco Packet Tracer we can install SNMP version 1, 2 and 3. Now how can you say that the installation is complete? If I get in the after installation, if I get the entire MIB tree, okay, the पूरा database का जो tree structure है, right from the root node to the last node, if I see the entire tree structure, then I can say that the MIB or the SNMP, that particular version is installed. Okay, so when I'm installing, because see, in any system, the database is the most important part. Okay, so I have to install the database. Now it is also said that when I am installing SNMP, it's not necessary कि मुझे हर एक database install करना है. Okay, one enterprise or one organization might be a small organization. So why to install the entire database? Because I might have unfilled data. I don't require that much data to be maintained in my database. So it is up to the user or up to the organization to install that much part of the database. So that provision is there in your SNMP. Okay, so What is the management database? So MIB2 we are using. 1 was never installed, so we never had MIB1. So they started working with MIB, and later part they worked with something, and then they came to the version 2. So if you start searching about version 1, you will not get any information. So it is specified in the RFC 1213, and the current standard is the 17 standard. So MIB is organized such that the implementation can be done on as needed basis. This is what I was telling you. Okay, because in every organization, the database is different. Okay, many of you have studied database management. So you know for every different organization how to manage a data. So the entire MIB does not have to be implemented in either the manager or the agent. See, MIB is there in the manager, MIB is there in the agent. Okay, what is there? Can anybody tell me what is there in the manager? What kind of database is there in the manager which is not there in the agent? Can anybody tell me that? Right now, I'm talking of the virtual database, that is MIB. Okay, so here, MIB from the sentence, it is already there. The MIB does not have to be implemented in either the agent or the manager. मतलब agent के पास भी MIB है और manager के पास भी MIB है. Which database is there in the manager which is not there in the agent? Can anybody tell that? You had a IA1 question also based on that. Yes, Abhishek. See, few people are not answering or just keeping quiet. What is this use then? Yes, Larry.
Database.
Which
Yes.
database? Yes, yes. Somebody said something. Which database is there in the manager which is not there in the agent? There is a name. Minita. I have to take names.
Yes, ma'am.
Which database is there in the manager but not there in the agent?
Manager, not agent.
What is the short form? MIB जैसे है. What is the short form of that database?
MIB or M.
You are going to have an MCQ based exam, and all this will come. MDB, management database. MDB, remember we had drawn also in the architecture. How does MDB ka alag way mein draw kiya tha? MIB is a virtual database. Okay, so MDB is the permanent database which is there only in the manager. The agent does not need to have a permanent database. It is the manager who needs to have a permanent database. So the permanent database is called as the management database, MDB. And the virtual database is called as your MIB. Okay, so the managed objects are accessed via this virtual information. See, why virtual information? It's not something permanent. The agent takes the value of the counter, stores it. Okay, he sees what is the packets that are being handled. Okay, he stores that data. That data need not be stored throughout. Okay, if the manager is asking for the data of that counter or how many packets was sent during that particular hour, he will just transfer that information to the manager, and the manager might store it in his permanent database for the performance analysis and for all those tracking. But the agent does not need to maintain all those, so that those data permanently. Okay, might be for a specific amount of time that data needs to be there. So that's why it is a virtual database. The manager also has a virtual database, but the permanent database is with the manager. Okay, now this already you know. Objects in MIB are defined using the ASN1 standard. So if I go down the tree, so there are 11 groups in the MIB tree. So internet already you know 1.3.6.1.2. Okay, the object identifier. So I will show you. इसके आगे वो OSI tree था. If you remember, I cannot have that entire tree diagram. So internet object identifier is 1.3.6.1. Under internet, we have many clause. वहाँ पे देखो ऐसे line था. Okay, but what we are studying under us is internet management. We are studying. Okay, that is our chapter. So we are bothered about only management of internet. So in internet, we have directory management, experimental, private. Okay, and these are the identifiers that are given. But since we are only studying the management of internet, so we are coming under this. So management, so internet management identifier 2. So यहाँ से आया 1.3.6.1.2, and under that we have MIB2. Now under MIB2 we have this 11 groupings of MIB2. Now see, when I say that I'm installing the SNMP, I will see this entire tree diagram. Okay, in the whichever software, in packet tracer में तो तुमको पूरा ऐसे ही दिखेगा एक के बाद एक. Okay, so when we come to the last point, okay, we say that yes, it is installed in the system. Now here, if you see or if you refer to my notes in the Moodle, you can see yahan the tree diagram does not end over here. System will have, so these names we will study in detail in the next lecture. So under systems group, there will be again 7 to 8 category. Interface group, there are so many interface. Again, there will be so many category. AT, address translation group, there will be so many categories. So the tree diagram will go on increasing. Okay, and if I go to SNMP version 3, this is one level, this is another level, this is another level, this is another level. There are 72 such levels. Just imagine, ये इसके आगे तो कितना था, DOD था, root node था. Okay, so all those things were there. ISO tha, ITU tha. So, and so that was level 1, level 2. So 72 such levels will be there. And it is impossible for you to remember all those levels and tables. In my notes, everything is included, but that doesn't mean you have to prepare it. But out of these, there are some important aspects which you need to know. Okay, so just a systems group hai, so we need to know what is the systems category, kitne type ke systems hai, and so on. So if you are referring the notes, please try to draw it, because it's during only lecture I have observed you draw it, because while you are preparing for the exam, you don't draw or practice it. And if any one of these identity is wrong, okay, you will not be awarded marks, because any object is having an identifier, and if that identifier is wrong, your ASN1 coding will be wrong, your TLB encoding also will be wrong. Okay, so in the next lecture, I think it's already one, so I will be continuing